My goal is to really present a topic that I had presented at a conference not too long ago, and it got some pretty interesting reception from people. And the other thing is that we're hearing this topic discussed from a lot of our users and other people. The question comes up, and I thought it'd be a good opportunity to present the webinar. And let me get this started. Yeah, talk about the topic in the sense of three main areas for the basis of the discussion. One is the current state of construction and VDC practices, VDC being virtual design and construction. And number two would be sharing some of what we've seen and heard from Synchro users in various places and in various industries. The feedback we've gotten has been quite interesting, and I want to share some of that. And three is really based on what we know within the company and from what we've seen users do can be done using the capabilities of our software platform. So I want to also mention that please feel free to send questions, and I will make sure that we have time at the end to answer the questions. Also, just a note that this is scheduled as a 30-minute webinar. I feel that it will get completed before that, but just want to remind everybody because sometimes we have 15-minute webinars and sometimes we have 30-minute webinars. So really, I want to introduce this topic. What is in the schedule in today's construction projects? Today's construction projects, or particularly the larger ones, are more complex than ever, and yet everything is driven by the schedule in terms of planning these jobs. So the question, which is somewhat provocative, is really what is in the schedule? One thing that's in the schedule for sure is increased design complexity. With the advent of BIM and the advancement of the data management and data capabilities within the BIM models, the design models that are being created are more complex than ever and increasing in complexity. This gives a lot of flexibility and freedom to those who are designing facilities, utilizing these tools, but it also presents challenges in terms of how to schedule the construction of these projects that are based on these design models. And the scheduling complexity is a derivative of the design, but is also presents an opportunity to create ideas and methods for improving the process by which these facilities are constructed, given the data that's retained and presented in the models for design. Design complexity then is in the schedule. In addition, construction planning is in the schedule. Everything that's done in a project is going to be in the schedule in one way or the other. It's either directly in there and followed, or it's not in there and confronted at the site. But everything that's done is scheduled in one way, shape, or form. And the complexity of how these projects are constructed is increasing in ways that are driven by schedule and driven by the complexity of the design and driven by the scale of the projects and driven by the logistics. The construction is complex and the schedule needs to account for that. Another thing we're seeing is an increased level of awareness in owners' requirements on projects, not only in the area of BIM per se, but in more specific detail regarding construction planning and construction reporting from the BIM model. The slide that I'm showing right here is taken from an actual RFP from an owner on a major airport project, and while it mentions what they call the BIM system in every line, it does not mention, say, 4D specifically, but if you look at some of these requirements, they're quite detailed and quite focused on the visualization capacity of the schedule. For instance, the BIM system shall make it possible to visualize the correct progress of construction and equipping of the works. The BIM system shall generate an animated model representing the planned construction sequence. So there's requirements, as you can see, on coordination, there's requirements on visualization, and most of all, there's requirements on integration with scheduling platforms and transparency that is being required and desired more and more by owners. So The challenge will be, as these become more common, is how do we deliver on these requirements utilizing the methods and practices and tool sets that we have. So the first question really is how can a traditional schedule effectively be used for today's projects? The complexity, the requirements, the design all feed into what I would say is an almost impossible task to use a traditional CPM schedule to plan the job and accurately maintain that plan through the life cycle of the project. There is an absolute need for visualization of the schedule, and it needs to be accurate and timely. What we see on the screen here is a workflow that Synchro uses for visualizing construction schedules. And a lot of you that are using Synchro are using this workflow, have seen this chart. Some of you have not used Synchro before, may not be aware of this. But the bottom line is that data comes into Synchro from design models, and data comes into Synchro from schedules. And the way it's viewed in the program is aligned quite intuitively with how it's viewed in the schedule. And I think that's an important factor that needs to be looked at here, is that there is an advantage in being able to visualize what you've got in the schedule based on this complex design data. So the question is how to maximize the effectiveness of this and plan a workflow that's going to keep this process moving to the advantage of all the stakeholders involved. So the first question really is that we get asked quite frequently is this one here. I know 4D modeling is a great tool, but why is it so important for scheduling? I'm going to go over a few aspects in response to this question. The first one is there are errors in the schedule. This is an absolute. It's virtually impossible to create a schedule and plan the sequence of complex works without errors. The question is, when are you going to discover these errors, and how are you going to discover these errors? In this project here, which is a very well-known project in the UK, in London, the tallest modern skyscraper, I believe, in London, the Shard, and this was done several years ago with Synchro. A very effective use of Synchro on this project, a very effective use of 4D. One of the things that came up was just the ability to identify issues that were in the schedule but would create conflict in the field if not detected earlier. And in this example here, you see that the construction of the steel at some point jumps ahead of the repositioning of the crane, or the jumping of the crane. So if this was not found, and this is a typical example of the kind of things that happen regularly on construction projects that are dealt with at the time that they happen, but they cause delay and they cause time wasted. So in this case, the steel is jumping the crane because the activity is started earlier in the schedule than the repositioning of the cranes. So by finding this, this is almost impossible to find in a traditional schedule, but by finding this in the 4D, they're able to make the adjustment before the work actually occurs and move on from there. So just an example of what I would consider to be a fairly typical error that happens in some cases multitudes of times in a construction schedule. The second thing is there are delays in the schedule, and the question is, are these delays identified? Are these delays acceptable? But the main value here is that the ability to visualize and also re-baseline schedules in Synchro enables one to actually visualize the delays and determine methods for alleviating or mitigating the consequences of these delays and correcting the schedule moving forward using the techniques that are enabled through interrogating the model and working within the scheduling tools within the software. What you see in this example is simply the baseline on the left and a more current version of the schedule on the right, and the areas in which the schedule has fallen behind that can be easily seen by the project team. And it can be seen in the Gantt view, and it can be seen in the 3D window view, and it can be seen on the calendar. So if I'm in a meeting and I just stop and I want to know, for instance, where are we at on October 20th, for instance, here's where we're supposed to be at, here's where the current plan is, what are we going to do moving forward? There are delays in the schedule. The value here is being able to deal with them as early as possible. There's also opportunities in the schedule. Before I continue this video, I want to explain that in many projects that I've seen, schedules are made based on historical data that's developed from scheduling from previous similar projects, particularly in industries like power plants. And they all look natural and they flow well within the CPM view. But what can happen is that opportunities for improving the schedule or dealing with delays in a creative manner are not considered, even when they seem to be obvious once the situation happens, just because they look normal in the schedule. Here's an example where on the left there's a tank that is scheduled to be installed, the one that's green, but what happens is the delivery of these last two tanks is delayed. And so in the schedule, for instance, if they're delayed by a month, the activities get pushed by a month, and since they're on the critical path, the whole schedule essentially gets pushed by a month. But on the right, what you'll see is that due to this situation, the team gets together and actually reconfigures their plan for constructing this facility by considering that, based on the fact that the first 4 tanks were installed, that they can start constructing the upper parts of the steel structure before the last 2 tanks arrive and not lose time. They can also, because of the visualization and the ability to pull everybody together, they can include the structural engineers in this discussion to make sure that what's being suggested as an alternative plan is actually structurally feasible and sound and safe. So that what ends up happening is the tanks are delayed late, but the structure is actually completed earlier, and what originally looked like a given delay in the schedule actually turns out to be completed earlier because of the ability and the opportunities that are presented in the schedule when used in the 4D environment. The next topic is there is waste in the schedule, and this is an increasing area of interest in the construction community, that the waste in the schedule is being looked at in terms of lean practices to find ways to be able to reduce the waste and expedite and streamline the process of construction. Current methods include pull planning and so forth that are done using tool sets that are collaborative by pulling subcontractors together as a means to focus on a milestone, look backward from that milestone, and be able to sequence and collaborate on the planning of the activities in a coordinated manner leading to that milestone. And that's done typically using markups and sticky notes and so forth. What would really become even more powerful and valuable is adding 4D to this process, because by adding 4D to the process, you're able to more quickly communicate what's being discussed and be able to actually visualize it on a sequential basis based on the actual model and design of the project. So for instance here, this is basically a straightforward flipbook approach from Synchro output that's derived from the discussions that are being held for the pull planning. This is being done on an actual project, a major project, an IPD, Integrated Project Delivery project in the US. So again, there's waste in the schedule, it's a given. The Synchro 4D enables the ability to look more closely at that in cooperation with lean practices and enable an even more effective workflow that's more easily communicated and actually, in context with the previous slide, offers further opportunities to optimize and reduce waste. Think about the use of Synchro, think about the use of 4D in context with full planning. The next topic is risk. There are risks in the schedule. It's a given. There's a lot of work that's done by project teams and planning teams to what they feel is eliminating risk, but a lot of times what seems to be something that's actually eliminating the risk or reducing the risk can actually create more risk. And that is not necessarily easily figured out without the use of the visualization in the 4D. For instance, the topic in this case would be prefabrication. Prefabrication is being used a lot more in projects and a lot more in terms of reducing on-site construction work by prefabricating assemblies, prefabricating components off-site and delivering them to the site in a so-called leaner fashion, which is a great practice. But what can happen is that the increased size and complexity of the prefabricated assemblies may prove to be more difficult to install than what is forecasted by the planning team in the schedule. And so what happens is you can have the prefabricated assembly delivered to the site and then hit a delay due to the fact that it literally has an obstacle before it can be installed. And this is an issue that's come up in, for instance, a project here in England where the use of Synchro enabled them to basically digitally rehearse the planning of the installation of the prefabricated assemblies in a manner that ensured that there would be no obstructions during the process. And that creates a sense of awareness of how to best conduct the work, and also a sense of validation that the work will be done as planned, and also presents the opportunity to figure out ways to reduce the amount of time it takes to install. So again, there are risks in the schedule. They're given. It's in there. 4D can enable the ability to evaluate risks that are known, but also evaluate what we call unknown risks, such as the one I described. There is progress in the schedule. Synchro's latest technology enables the ability to track progress of works at the job site and via the API that's connected between the mobile technology and Synchro Pro to visualize these changes in real time in the program. And this is really valuable because this presents an easy way for teams to look at their specific area of work and on any given day look at exactly what was planned to be done and what was accomplished in the field. So there is progress in the schedule. It's very difficult to update the status of activity, the status of progress in a schedule on a complex project. These tools enable you to do this more intuitively and more productively so that progress tracking in the schedule in the 4D environment can be done. It's actually doable now, and it's a very effective way to accurately track progress in the schedule. And finally, for my last example, I'll just say that there is truth in the schedule. The schedule is a document of record. It is a document of what's been planned to be done in the field. And what we see is that in claims litigation, for instance, that the use of 4D is very effective and is becoming more popular because it enables the contestants who are disputing a situation on a construction project to actually visualize what happened or what was supposed to happen based on the real data, based on the actual design model, based on what was changed in the field, and based on the actual schedule that's been developed and recorded. So if in the situation like shown here, that you have a change in the condition at the job site that's initiated by the client in terms of, say, adding another subcontractor to the job site, it disrupts the work that's being done by the other contractor in terms of crane operations. And the contractor would say, you know, this addition of the other contractor is reducing my ability to perform as many crane picks as I've got scheduled. And with the use of Synchro, for instance, they can then look at, first of all, optimizing the best way to do it given the new conditions and new constraints, but at the same time demonstrate in a technical, accurate manner what the result of the implication of this is on their schedule. And this becomes, say, an ability to convey to the owner in a clear and easily articulated manner because of the visualization what's going to happen to the schedule. Without this, it would be extremely difficult using the CPM schedule alone to be able to basically visualize how all this is going to play out with the changes that are occurring. So another question that's asked is, given all this, a lot of people ask and are wondering, when should I start using 4D for scheduling? Because there is some ideas on, well, do I need a certain degree of detail on my design model before I can start? Do I need a certain amount of detail and level of scheduling before I can start? And the answer is that it should be started as soon as possible, but more to the point, that as you can see in this chart here, that you see that there are progressive utilization of 4D through the life cycle of the project, and it becomes more and more involved and more valuable as you progress from the point of starting the process by integrating model and schedule data into a 4D environment, and then adding information as you go along in terms of resources and cost, using the tool to conduct progress review meetings to validate the plan or find errors in the plan or improve the plan, and also then to look at ways to reduce risk as the project progresses due to situations that may come up that are unforeseen at the beginning, attacking them early, looking at the possibility of safety hazards and clashes, and then optimizing as you move forward every step of the way to be able to look at that issue of waste and lean and be able to continuously remove the waste from the process as you progress through the schedule. And then in the field, being able to actually track what's being done more quickly and more effectively so that the status is recorded as close to real time as possible for the project team to review and make adjustments if necessary. And then at the end, to be able to look at the model as a means to compare situations that may have happened and been fixed, to be able to compare the use of the model to other areas that may have not been using 4D, then to be able to collect metrics on this process, to be able to determine the return on the investment and the metrics and the value gained from this process so they can be used moving forward. So in conclusion, how can Synchro take me to the future of scheduling? And what we've got is a lot of resources that are available to you, whether you're using Synchro as an experienced user, whether you're new to Synchro, whether you're considering Synchro and haven't started it yet. We have resources available. There are videos in our YouTube library that are a great way to look at different workflows that are done that attack various areas of the chart that I showed previously in terms of how to use Synchro to accomplish these tasks. We offer training in our offices and also at your job site, your project office, if interested, to get you up to speed quickly from our experts to be able to accomplish as much as possible with 4D scheduling. And we have a project delivery team that I manage that is available at any time to help you out with questions, to help you out with project issues that you may confront, and especially to help you achieve the maximum value and ultimate success that you want. But the bottom line is you want to get using our software platform and use it in the office, in the trailer, in the field, and make it part of your regular workflow and not just a tool that's pulled in for extraneous purposes. So in conclusion, we want to hear from you. We have an email address here, spd@synchroltd.com. We'd love to hear your stories about how you're utilizing the software, on the kind of things that you're confronting on your projects, anything that you want to share with us that you feel we can come back and help you with. We want to hear from you.